Hello, I'm Chuck Ridgway, Automation Technology Manager here at Horner. It's Tuesday, time for another technical session, another live stream. Today I think we've got a fun topic for you. Today we're going to be talking about some unique Cscape ladder logic function blocks. And joining me today is my colleague in crime, Mr. Casey Gardner. How you doing today, Casey?
Hey, not too bad. How's it going, Chuck?
Great. Now, as I was kind of reviewing the material, before I presented today, I was going through and kind of thinking about some of the applications where I've used some of these unique function blocks. And there were a couple that I really haven't used all that much. How about yourself as you took a look at the material?
Yeah, I think one that really stuck out is that key press source capability. I've gone and used things around it or similar to it in numerous ways, but I didn't realize it had the functionality it did, which is really nice.
Yeah, Casey's talking about the key press function block, and we're going to cover that in detail along with several other really unique Horner advanced ladder logic functions. Now, Casey's going to be manning the chat. If you're watching us live, go ahead and chat your questions in. He'll get them answered, or he'll save them until the end when we get back together again. If you're watching this on replay, we still want your questions. Just type them into the comment section and we'll answer them in non-real time. Okay, let's go ahead and get started. All right, unique Cscape function blocks. So the first thing we're going to cover is, what makes these function blocks unique. That'll be an interesting couple of minutes there. And then we're going to go through all of the blocks you see here on the screen. From scale to limit, day of the month compare, bit set, bit clear, a bunch of file functions for removable media type functions, label functions, jump functions, and what Casey and I were talking about a minute ago, and that is the key press function. So let's go ahead and get started. Okay, so what makes some of these Cscape ladder logic function blocks unique? Well, some of these are unique to Horner. You won't find them with any other manufacturer, and so that certainly is unique. Others, while they may be available in some ladder logic language sets, including our own and Cscape, they may be outside the list of the typical ladder logic functions that are familiar to most users. So we think it's a good idea to talk about those so you know they're available. Some solve some unique issues, including that key press function that Casey and I were talking about, and some are just really useful in general, and so we want to make sure that you don't overlook them. All right, let's start diving into these unique function blocks. We're going to start with one that we've covered before as part of some of our other technical topics, but it's a really important one, so I'm going to cover it again today. And that is the scale function block. So the scale function block can be found in the instruction toolbox under advanced math. Okay, and this function makes scaling analog inputs over to engineering units, makes that really easy. All right, so you typically have an input variable, which is almost always either your analog input signal directly coming into the AI register, or it's a version of that particular value that's been converted to a real number and then used in a floating point version of the scale function block. So you've got your input variable, a minimum and maximum that you're expecting from your input variable, and then your output variable, which is what the scale block is going to write to, along with the minimum and maximum that you want written on the output side. Okay, so it's really an important function block. Let's head over to Cscape and take a look at that guy. Again, with all of these functions, we're going to cover these in terms of demonstrations for all of them. So I've got some example code here that's utilizing the scale function block. So we're going to start with an example where, let's say we've got a tank level that we're going to be monitoring. We want to monitor the level of, let's say, fluid in a tank. And we might have a analog input ultrasonic sensor that has a 4 to 20 milliamp output, and that may be telling us the level of fluid in the tank, and that might be scaled from 0 to 10 meters, for instance. Okay, this could be a real big tank. Using this scale block here, let's take a look at how we might set this up. First of all, on the input side, I'm using this in integer mode to start with. On the input side, this is a variable that's just directly mapped to my AI register where my analog input is wired to. Okay, and that value is changing between 0 at 4 milliamps and 32,000 at 20 milliamps. So that's the input side. On the output side, we have our tank level, and we're just going to calculate it in millimeters in the case of this particular function block. And of course, 0 is the minimum, and 10 meters corresponds to 10,000 millimeters on the output side. Okay, so we're taking our analog input and we're scaling it over to millimeters in this case. Well, we may really want this information in feet, for instance. So let's take a look at another scale block that would convert from our 4 to 20 milliamp signal over to feet. All right, so what we're going to do is we're going to use a floating point version of a scale block. But in order to use that, we need to convert our analog input value over to another variable that's in a real or floating point format. So it's still going to be 0 to 32,000, but the value is going to be in a floating point form. Okay, and then now that's going to be the input of our scale block. And our output is going to be from 0 feet, which is the minimum, to 32.8084 feet, which is basically at 10 meters, that's how many feet is 10 meters. And when we execute that, we're going to get feet as the value in floating point with this particular output variable. One more just to show you, and that is just for the sake of convenience, let's take a look at what the milliamps might look like with any particular value in our analog input register. So this is another case where I'm going to stay in the integer form. Again, my analog input variable is directly mapped here from the AI. Input is 0 to 32,000. Output is going to be in milliamps, but what I've done here, instead of making this 4 and 20 for min and max, I've made this 402,000, which basically has a couple of implied decimal points there. So when I display that on the screen, I can stick a decimal point 2 spots from the right, and I can display on the screen what my milliamp readings should be if I stuck a multimeter in the system. Okay, so let's take a look at an OCS that's running this demo. Okay, so here's my tank level, and I have my handy dandy IO simulator connected here. So as I gradually increase my analog value, on the left in yellow there, you can see the counts coming into my analog input register that's scaled between 0 and 32,000. So as that rises, you can see my tank level rising as well in both millimeters and feet. And again, for convenience, I'm showing also electrically what I should be seeing on my multimeter between 4 and 20 milliamps. Okay, so that's, again, a piece of cake to execute that code, to write that code, to scale your analog inputs over to engineering units. Really easy, definitely a function you want to take advantage of. We're not the only company that has a scale function block like that, but they're not universally available, and it's one we definitely don't want you to forget for sure. Let's head back to our material now and take a look at our next unique function block. Here's another one we've covered before, but again, it's a really important one and I want to cover it again, and that's the limit function block. So the limit function block is a compare operation, and it can be found in the compare operations under the toolbox. And this function block is great for detecting normal conditions on your machine as well as alarm conditions on your machine. So how does this function work? Well, it passes power whenever the input variable that you're comparing against is between a low and high input value. So whenever the input variable is between low and high, then it passes power. If it's between low and high, it means it's probably normal. So that's logic you can use to detect normal. But let's say you want to detect if you're outside those range. Well, you can just swap your low and high variable, and now it's going to pass power flow when you're outside that particular range. Let's go back into Cscape and take a look at that particular function block in action. Let me move over from my scale section over to my limit section. And here we have a limit function, and what we're doing here is we have, let's say we're monitoring differential air pressure around an air filter. And if the differential air filter is falling in an acceptable range, it means our air filter is not clogged and everything's as we expect. However, if our air pressure gets too high, or let's say falls outside of the expected range, then we need to flag that as an alarm condition so that we can do something about it, like, for instance, change the filter. So in this first rung here, I'm detecting normal. Okay, if my current pressure is between the low and the high settings, then I'm normal. If my current pressure is in this scenario, you've seen I've swapped the high and the low settings. With this setup here, I'm going to pass power flow if the current pressure is outside of the expected range. Okay, so that's a great way to detect an alarm condition. All right, so let's take a look at that on the OCS. So let's go to our air filter maintenance screen we have here. And on the right side there, you can see that our current air pressure is at 0.485, and we're expecting it to be somewhere between 0.15 and 0.75. So because we're inside the expected range, our normal light is on, which is what we would expect. If I were to, let's say, make a change so that, or, in our simulation here, if I were to make a change and say the value would suddenly go above the expected, now you can see our air pressure raised to 0.8, and now we have an alarm condition. Okay, so that is the limit function. Again, a really handy function that you should definitely be aware of. And again, other companies have limits available, but again, it's at least somewhat unique, or at least outside the range of what people are used to. People, I think, are used to putting, less than and greater than function blocks together in order to do pretty much all their alarming that are level-based. In the case of the limit function, you can save yourself some effort in a lot of cases. Let's take a look at our next function. The next unique function I want to highlight here is our day of month compare function. Now, these can be found in our time and date operations in the toolbox. And this is an area that we covered with a fair amount of detail in a previous live session. So if you want to look up the date and time and the scheduling live sessions that we've had, you'll see that we've covered these functions in a lot of detail. However, this day of month compare function, I wanted to cover it again because it's a really useful function for anything that you want to have happen from a scheduling standpoint that may happen based on a certain day of the month. Now, I'm not talking about Monday, Tuesday, Wednesday. I'm talking like on the 7th and the 21st or the 14th and the 28th, that sort of thing. Okay, so the way this function works, it's a compare function, so it's again a power flow type scenario. It basically passes power whenever the day of the month, that is today, happens to match a flag from a double integer register that has a flag for every day of the month. So we've got a bit-mapped double integer register that has 32 bits associated with it. And for bits 1 through 31, each of those bits correlate to a different day of the month, the first, the second, the third, etc. And of course, the 32nd bit, since there is no 32nd day of the month, it's effectively ignored. But anyway, the way this function block executes is it checks today's day of the month versus the bitmap pattern in that variable. And then if today is flagged, it will pass power flow. So that's the day of the month compare function. Let's go back and take a look at what that looks like in Cscape. Now, there's not a whole lot to it from a Cscape programming standpoint. Okay, as I switch over here to the compare logic here to the day of the month compare. As you can see from a configuration standpoint, literally you have this bitmapped double integer that is the only input for the day of the month. And if again that bitmap happens to match the flag for today, happens to be on, it's going to pass power flow. So the next question I would get when I'm using this particular function block is, okay, this looks like a very handy function block, but what kind of code or what kind of approach do I need to take if I want to actually set the flags in this double integer variable? That seems like it could be complicated. Well, there's another function block we're going to talk about next that can make that quite a bit easier. And that is the bit set as well as the bit clear function blocks. So these are functions that can be found in the bitwise operations section. So bitwise operations are functions where you're working on bits effectively, okay? And there at the bottom, you'll see bit set and bit clear. Now these functions are great for independently setting or clearing a bit within a word or a double word, and it doesn't have to be just a word or double word. It can be literally a whole string of words, maybe that add up to 128 bits or 256 bits, whatever the case may be. Okay, so it's just a whole array of words, if you will. And it gives you the opportunity to go in and set a particular bit or clear a particular bit without disturbing any of the other ones. So again, that can be pretty handy. Now in the Horner command set or the Horner instruction set, we give you the ability using just regular old coils in your logic, in your Boolean logic, to work on a particular bit within a word without disturbing the others. So a lot of folks are used to the fact that you can just use, let's say you want to turn on the 7th bit of a particular variable. You can reference that variable .7 in your logic as a coil and turn that bit on. So that can be used kind of like a bit set. However, there are scenarios where it's easier to use a function block instead of Boolean logic. So let's talk about that a little bit. One of those applications where it's easier to use a function block than the Boolean equivalent is with this day of month compare. So if we want to go in and set a few bits in our day of month compare variable, okay, the particular bits in which we want to change our filter, for instance, in our filter example, then the bit set function block is a great one to use to get that accomplished. Okay, so let's go back into Cscape now. And now let's check out the bit set area of my logic here. And we've got a good example here. So what we have happening is this. In our application where we are monitoring the air pressure across the filter, we also want to just schedule as routine a couple days of the month where we're going to just plan on changing out the filter. Let's say the 14th and the 28th, for instance. Okay. So in order to make that work, in the previous rung that I showed you that utilized the day of the month compare, we have a 32-bit double integer variable with a flag for every day. And whatever flags are set, we're going to pass PowerFlow and set a flag that says, hey, we need to change the filter today. But the way in which we get those flags set in the first place is by utilizing the bit set logic here. Okay, so the first thing I'm doing is I'm setting my 32 bits. I've got 2 consecutive words, a total of 32 bits, that I'm using for correlating with the 31 days of the month. And I'm initially setting those all to 0, so we don't have our filter change flag set at all. And then I'm using 2 bit set functions, one each for the 2 different days of the month that I might want to change the filter, or at least schedule to change the filter. Okay, so I have a variable that is set from the touchscreen that basically is the day of the month I want to change it the first time, and the day of the month I want to change it the second time. So for instance, it could be the 14th and the 28th, for instance. And then that will set the bits of our day of the month double integer flag variable. And then back here under the compare logic, we will turn on our indicator that tells us, hey, today is one of the days you said you were going to change the filter. All right, so let's take a look at what that looks like on the screen. Okay, so there's my OCS. So there's my 2 days, the place where I can enter in from the touchscreen the 2 days of the month in which I want to change the filter. So I've got it set for the 14th and the 28th, and this live stream is on the 7th. So therefore, today is not one of the days in which I want to change the filter, so my indicator is off because my day of the month compare is false. However, if I decide that, well, let's do it on the 7th instead, well, today is the 7th, and therefore my indicator is now on because my day of the month compare is now true. So there's an example of how you might utilize the day of the month compare as well as the bit set command in a scheme in which you want to schedule the replacement of a filter, for instance, on a machine. Let's head back and take a look at our next unique function. Next, we're going to talk about some removable media file functions that can be really handy. And these removable media file functions are, surprise, surprise, filed under the removable media section in Cscape. Now, we covered these along with all the rest of the removable media functions in great detail in the removable media part 1 live stream that we did a while back, and there's also a removable media part 2. So if you're looking for even additional details than what we covered today, you can go back and check out those videos as well. But the rename, copy, and delete, those are just very handy, unique function blocks that can be used for general file handling, especially when you want to copy files, let's say data logging files or recipe files, for instance, from your micro SD drive over to a USB drive or vice versa. These functions also allow you, and again, we covered it in great detail in our previous live streams, they also allow you to utilize wildcards, things like file counters and the current time and date, in order to ensure that your file names are unique and your directory names are unique, so you don't end up overwriting a file you don't want to overwrite. You want to make sure they have a unique name. So that's the file rename, copy, and delete. Let's take a look at those functions in Cscape. So let me go ahead and let's start with rename. Okay, so here's a rename function block, very straightforward. One input and one output along with status. So I'm going to rename a file. So what file am I going to rename? Well, it's a file called capture.bmp. And when I execute this function block, I want to rename it as archive.bmp. And while I'm executing this function block, I want to have some status. So I have a status variable here that can tell me whether it's successful or not. Now, if I pass power flow, it basically means it succeeded. And then I have some other conditions that I can look out for in my status variable. And then if those occur, I can turn on an indicator that says, hey, my rename function failed, and I can take corrective action elsewhere in my logic. All right, let's take a look at how this might work on an OCS. So what this particular screen does, or this particular demo does, is we are going to rename, we're going to execute effectively the function block I just showed you. We're going to rename capture.bmp to archive.bmp. All right, and I'm going to trigger that just with a push button here on the screen. Now, it failed right away. Why did that happen? Well, one of the reasons it failed, or the main reason it failed, is because you'll notice that that file wasn't on the micro SD drive to begin with. Okay, so that could be a problem. That could definitely be something that could cause something to fail. So in my demo, let's go back to the tank portion of the tank screen, and let's do a screen capture of the tank screen, and then we'll actually have that file that we're going to rename available on our memory card. Okay, we take a look, and sure enough, capture.bmp is there, so now we should be able to rename that. Looks like it worked. And now we know for sure it worked because we now have a file called archive.bmp. Okay, so that is the rename function. Definitely handy so that if you're working on a file and you're done with it, you want to archive it away, or you want to give it a different name so that it won't be overwritten by the next version of that file that may be coming in from the data log or something like that, it can definitely be a very handy function. All right, back to Cscape. Let's move away from rename, and now let's take a look at copy. Copy is definitely one that you want to be aware of, because that can really be handy if you want to move a file, let's say from micro SD over to USB, so you have the old-fashioned way, the ability to grab a copy of a file directly from the OCS. So with that function block, again, we have an input side or a source and a destination side. Now, in our example here, we're going to copy that archive.bmp file from the micro SD card over to USB. How do I know it's USB? Because I've specified B:\\. Okay, so the B drive is the USB drive. And I'm not only putting it on the USB drive, but I'm also putting it in a subdirectory called captures. And underneath there in another folder that is based on the month, day, and year. And then the file name that I'm copying over there isn't going to be called archive.bmp. It's going to be called a file name .bmp that's based on the hour and minute second that I went ahead and did the copy. Okay, so that's what we're going to execute next. Let's go back to our OCS and let's go ahead and see if we can execute this. Oh, I'm still on the rename screen. Let's head over to the copy screen. There we go. Now you'll notice it took a little bit longer because we had to copy that file from one drive to another. It takes a little bit longer than if you're just going from one drive to another location on the same drive. Okay, so now you can't really see it, but our USB drive that I have plugged into the XL7 here now has the copy of archive.bmp, but it's using that hour, minute, second file name within the folder that we've specified. All right, finally, let's go back to Cscape for one last file type function, and that is the delete function. Very straightforward, as you can imagine. All we're going to do is identify what file that we want to delete. Okay, in this case, we're done. We've copied archive.bmp away. In our workflow here, we're going to go ahead and delete it. Now, you can use wildcards like star.star, for instance, or you can specify a particular subdirectory with star.star, so that if you want to delete a whole set of files within a folder, that are of a certain naming style, you can do that. Okay, so you don't have to specify to every character the exact file name that you want to delete. In my case, though, that's what we're going to do. Let's head to the OCS and just make that happen real quick. Okay, so here is the delete screen. The file we want to delete is still there. And now it's not. Okay, so that worked. All right, let's head back and take a look at our next function block. The next one I'm going to show you is a really important one, but one you have to use a lot of care with, because with power comes great responsibility. And those are the label and, more importantly, the jump function. So the label and jump functions can be found under special operations. Okay, and that's the toolbar you'll find those under. Now the label is pretty harmless. It's great for program organization in general. It's good for labeling just a section of your code that you may want to jump to using a jump instruction. And most of the time when you use jump instructions along with a label instruction, usually you're jumping forward in the program, skipping over a section of logic, and that's fairly harmless. But if you want to create a loop, which is the other great thing that jumps can be good for, you have to be very careful that that loop is not an infinite loop. Okay, because if it's an infinite loop, you can cause your program or your controller to sit there and just reset continuously, which is obviously not what you want. So again, the jump function needs to be used with great care. Okay, let's go ahead and take a look at Cscape here. And let's take a look at a section of code I wrote here that utilizes the label and the jump. What we're doing here is in this example, we're saying that we've got a barcode that we're reading in. And included in the characters that we're reading in from the barcode are characters that we can print, and also some characters that aren't printable. Maybe things like carriage returns and line feeds and end of files and those sorts of things. So what I want to do, since I'm going to be printing this barcode, and I may be storing it away in a digital format as well, what I'm going to do is I'm going to go ahead and strip out any characters that aren't printable. And the way I like to do that, or this sort of thing, is I like to utilize a loop, and I like to go into the string that's containing my barcode, and I want to examine each character individually, one after the other inside the loop. And then as I examine each character, I want to take a look and say, hey, is this a printable character? If it is, I leave it alone. If it's not, then I'm going to replace it with a printable character, which typically is, I'll just use a space character, which is decimal 32. Now, how can I tell if a character is printable or not? Well, the way I can tell that is simply by taking a look at its ASCII value. If the ASCII value of a character is below 32, it's not printable. If it's 32 or above, it is printable. That's just how you know. So here's what we've got, and that is we have some logic where we're going to go ahead and execute the area between the label and the jump as a loop. All right, and what we're doing in that code is we're examining character by character our barcode string and making the corrections I just talked about. Okay, so when we decide we want to fix our barcode, this contact is going to turn on. we're going to reset a character counter to 0. And in my case, I've got a barcode that could have as many as 20 characters in it. So ultimately, that character count could go up is going to go up as high as 20. Okay? Now, here's the start of what my loop is going to be. The first thing I do is I'm executing my loop that's going to fix the barcode, is I'm going to execute this indirect move command. What does this indirect move do? Well, effectively, it is examining my current barcode string by extracting the character that corresponds to my current character count. And my current character count is a 0, which means I'm going to look at the first part of the very first character that's inside my barcode string. Okay? So that's effectively an offset, remember. And offsets always are 0 based. Okay, so on the first time I am going through my loop, I'm going to be pulling out that very first character and storing it away in another variable called character to check. Okay, so that's going to be the character I'm going to check. All right, I'm going to check to see if that character I just extracted is less than 32. Actually, I'm going to check to see, if it's less than 32. If it is, it's not printable. So therefore, I want to replace that character with a space, which is 32. And then using another indirect move going the other direction, I'm going to restore that character back into the same string that I took it from in the first place. Then after doing that, I'm going to increment my character counter, check to see if I reached the 20 characters, which is the end of my number of times I want to go through the loop. If I haven't, I execute my jump command, go back here to the label, and I do it all over again. So I'm going to execute this a total of 20 times. And when I'm done with that, I'm going to fall out of the loop and reset the flag that put me in it to start with. Okay, so that's the logic I'm going to execute. Let's take a look at the OCS here. All right. Here's the section of code, or the section of touchscreen type graphics that correlates to the logic I just showed you. So here's a display of the barcode that I have taken in. And you can see it's a Horner part number HEXE102AA, and then you'll see a couple of boxes there. Those happen to be carriage return and line feed characters that are not printable. So I want to strip those out. So when I press this fix button here, it should execute my loop, and it should take out that carriage return and line feed, but leave everything else the same. Sure enough, worked like a champ. All right, very good. So that should give you an idea of how useful it can be to be able to execute a loop sometimes. But again, treat that with great care, because if you forget and don't troubleshoot it, or you make a mistake, you could cause an infinite loop, which is going to cause your controller to be sitting there resetting. Not what you want, of course. All right, let's head back and take a look at one last function, and that's the one that Casey and I were talking about in the opening. That's the key press function. It can be found in the toolbox under special operations, the same area where we just dealt with the label and the jump. Okay, but what is the key press function useful for? Well, first of all, it is useful for replicating the function of a specific user interface key, but instead of touching the screen or using an OCS key to execute that key, instead you're going to use a dedicated physical push button that's wired to a digital input. Now, why in the world would you ever want to do that? Why wouldn't you just press the button on the screen or press the key on the OCS? Well, there's a couple use cases which are very useful for key press. The first, which I don't have detailed on the slide here, is a scenario where maybe somebody is going to be pressing a button on an XLE, for instance, which is a key-based operator interface controller. But maybe they're going to be pressing a button on that particular XLE all day, every day, and you don't want that button to wear out. I mean, it's good for approximately 1 million operations, but when you're pressing it continuously, the key eventually is going to wear out. So you could replace that particular key using the key press function and hardwired that key press over to a dedicated wired push button that is probably not going to wear out quite as soon. And if it does, well, you can replace it with another hardwired push button without replacing the OCS. So that's one use case. Another use case is in a hazardous location where, let's say you've got a OCS mounted inside of a explosion-proof enclosure that has no way for the user to touch the screen, but it might have a clear, thick window so they can see the screen. So in that scenario, in order to give them as much functionality as they may need to be able to enter data and those sorts of things, you might want to replicate the up and down arrow and the escape and the enter key using hardwired push buttons, which can then be on the outside of the appropriate explosion-proof rating. Okay, so let's see how that works. Again, back to Cscape. Now, there's not a whole lot to the programming of the key press function, just a couple things to be aware of. First of all, in the function block, you need to assign a variable for each key press that you're going to be replicating. You need to assign a variable that is mapped to a hardwired digital input. So in my case, I have a variable for the up key called in_up_key. And if we look down here in my program variable list, if I were to scroll down there, and I'll do that now, and find that particular variable, there we go. The up key is mapped to %I1 because presumably there is a hardwired push button that is going to replicate the functionality of the up key. And you'll notice for the down, escape, and enter, we also have hardwired inputs allocated or mapped to those variables. Okay. Now, one other thing that's important to note with the press key function block, and that is it never passes power. So you can't have a whole string of these in series on the same rung, or only the first one will execute. So therefore, they need to each be on their own individual rung. Okay, let's go ahead and see if we can replicate one of the real-world applications where you might use the press key function. So let's imagine that we've got an XL4 mounted in an explosion-proof vessel where we can see the screen but we can't touch it. And we want to be able to provide some user input using the menu object, and we're going to replicate the up, down, escape, and enter keys using push buttons, explosion-proof push buttons, and obviously using the press key function as well. So I've got an XL7 here with a menu object shown in the center, and I've hardwired through my handy-dandy I/O simulator 4 inputs, which are going to be slide switches instead of push buttons. Push buttons are always better, but we should be able to replicate it for this demo with slide switches. And let's see if I can manipulate this demo object, this menu object, so that we can, let's say, change our fuel selection and maybe look at some diagnostics or something. Let's see what we can do here. First, I need to hit enter so I can get to my fuel selection. Next, I'm going to use up arrow to change to a different fuel. I hit that twice there to get to propane. Hit enter again to accept that. Okay, let's hit down arrow a couple times to get to our diagnostics. Enter again. There we go. Okay, so as you can see, it's really not that bad to utilize push buttons to replicate some touchscreen functions, in this case, up, down, escape, and enter, using the press key function. All right, now before we wrap things up, I want to go over again with you, or go over with you for the first time, a couple of unique functions that will be going away in Cscape 10. None of the ones that we've covered so far, these are staying put, but we have a couple of unique functions you may have noticed under special operations that are tied to obsolete products. So that includes the stepper move function block, which is tied to our obsolete stepper indexer smart stack module, as well as our alarm handling function block, which is tied to our text-based OCS units that were first released back in 1998. So we have since come up with better approaches for both stepper moves as well as alarm handling. Our alarm handling is quite advanced and it's included in our graphics editor, and there's a lot of additional improvements coming in Cscape 10. So these two particular functions will be going away, whereas the rest of the unique functions we talked about today will be staying put. Okay, let's go ahead and bring in Casey Gardner. And Casey, I guess I'm I forgot to hit go live on YouTube. And so therefore, we probably didn't have any live YouTube viewers until most of the way through the presentation. But that's...
No, it was actually a couple minutes in. I caught it right after I exited. So yeah, they've been watching. There's a few of them.
Okay.
So
very good.
No questions. It doesn't look like though.
Okay, very good. Well, that's one way you can definitely tell when that our sessions are live is when we have little glitches like that. So sorry for the technical glitch, but looks like thanks to Casey, we recovered fairly quickly. Okay, thanks Casey for manning that. I want to remind our viewers who are watching on replay, don't forget to type your questions in as well. Just do it in the comment section, and we'll get those answered. Okay, very good. Lastly, I want to remind you, don't forget to subscribe. For those of you who haven't already, that way if you subscribe and you select the notifications bell, you can be notified every time we go live, and also every time that we post a new video, whether it's a pre-recorded video or again, another live session. And then from the standpoint of next week's session, we have for you, just like every Tuesday at 2 o'clock, we have another technical session. And next week, it's going to be hands-on with C-scan protocol. Now, we have done a couple of sessions on C-scan that were very popular. Again, C-scan is Horner's proprietary CAN protocol that's most commonly used for I/O expansion. We've done live sessions on how C-scan works, as well as installation and troubleshooting. This session is going to be all about having multiple OCSs communicating with each other in a peer-to-peer fashion over C-scan. It's a really great application for distributed control, can be used in material handling applications, any modular type application where you may have multiple multiple stations on a machine, and you want the individual stations to be controlled by an individual OCS. We'll show you how those OCSs can share data, and how even with a fairly large system that may have a dozen controllers or so, all connected and working together, you might just have one logic program running in each of those 12 controllers. We'll show you how to make that happen. Once again, my name is Chuck Ridgway, Automation Technology Manager here at Horner. We ask you to stay safe, and we'll see you next Tuesday.